And we are told that we are given sample standard deviation. Sample standard deviation is equal to 6.3. Determine if the population mean is different. So the given population mean is 26. All right. So the first thing we have to do is determine the null and alternative hypothesis. So state the claim. So state the claim. All right. So to state the claim, I would say mean of the population is equal to 26. You always use equal sign with the mean. By the way, you have to start with HO. So they already wrote HO for us. And then what are we testing? It says it's different. It's different. So it's a two-tailed test. So how do I write two-tailed test? Mu is not equal to 26. So this is a two-tailed test. Two-tailed t-test. So I know it's a two-tailed t-test because they say it is different. Calculate the p-value. So they want me to calculate the p-value, everything. We're going to calculate everything together. So what else am I given? I'm given that alpha is 0.01. All right, so we already know what to do. So what I'm going to do, I'll put everything in my, go to stats, arrow to test. I'm doing a t-hypothesis testing. So that is number 2. And then it's asking me, what are you given? I am given statistics. The mean is 26. The mean of the sample, let's see what the mean of the sample is. The mean of the sample is 31.2. So 31.2. And the standard deviation is 6.3. 6.3. And the sample size is 15. So I'm told to do a two-tailed test. In other words, I will select not equal to. How do I know that? Because it says it's different. It's different. So it's a two-tailed test. So I am going to draw. All right, so now I have seen from my calculator that the critical value, the test statistic is 3.2 approximately, and p-value is 0.006. P-value is 0.006. So p-value is less than alpha. Alpha is 1%. And p-value is 0.006. So now we go to p-value, right? 0.006. 0.006. That's what we found. State the conclusion. Because p-value is less than alpha. 0.006 is less than alpha. I am going to reject the null. Reject the null hypothesis. Therefore, it says determine if the population is different. So the population is different. Population is different from what is given to us now, 26. The population is different. So the conclusion, reject the null hypothesis because p-value is less than alpha. Reject the null hypothesis because p-value is less than alpha. So that is the conclusion. And then I'm going to move up again. So I rejected the null hypothesis because p-value is less than alpha. Let me go back to that question. Going back to the question. All right. So this is number 36. Okay, so the conclusion. So we have already concluded. So we said, I can say there is not enough evidence to state that the mean value is equal to 36. There's not enough evidence to say that the mean is equal to 36 because we rejected the null. All right. Any question? So we are actually reviewing, so we can be faster. Let's see if we have any other question there. Okay, that is 36. Well, let's go back to another question. Okay, I'm looking for a question on T. Question on T. Question on T. All right. So look at number 4. Number 4 is a T question. Number 4 is about mean. 34. Number 34 is about mean. The average daily volume of a computer is in 2011 is that. So given the mean is 35.1, according to a reliable source, a stock analyst believes that the stock volume is 2014. That is different. It says it's different in 2011. So a stock analyst believes that it's different. Based on random sample of 40 trading, so random sample is 40. He finds that the sample mean is 29. Sample mean is 29.5. With a standard deviation of sample standard deviation of 14.9 million. Test the hypothesis by constructing a 95% confidence interval. And by the way, whenever I'm doing a two-tail test, I can actually use confidence interval. We can use confidence interval to test the claim. So I'm going to, first of all, state the claim. So the claim says that the mean is equal to 35.1 and the mean is not equal to 35.1. Okay, construct a 95% confidence interval. So I am going to construct a 95% confidence interval. I am already given the X bar. X bar is 29.5. That is X bar. And this is lower bound. This is upper bound. All right, so I'm going to my calculator to use confidence interval to do the hypothesis testing. I'm going to use confidence interval to do the hypothesis testing. All right, so I go to Stat and Test, and then I'm doing a t-test because I don't know the population standard deviation. And the mean of the sample is actually the one given to me is 35.1. So 35.1. And the X bar is 29.5. 29.5. And the mean of the sample standard deviation actually is 14.9. 14.9. And sample size is 40. And then I'm doing a two-tail test. By the way, I'm using T interval, hypothesis testing now, but I will also do the test by confidence interval. So I am going to draw, so I can see that the confidence, the mean actually, so the t is negative 2.377. In other words, the test statistic, and then the p-value is 0.0225. Okay, well, let me quickly go and do the t interval and see what happens if the status quo is contained in the interval. I will accept the claim, otherwise I will reject the claim. So everything I need is still here. So I am told to do 95% confidence interval. Let's see, make sure that it's, yes, 95% confidence interval. So that is 0.95. And then I'm going to calculate. Okay, so I have 24.74 on one. So I'm going to put the confidence level here. The left bound is 24.74. 24.74. The right bound is 34.27. 34.27. So I'm going to check the mean. Is the mean of the population, the status quo, is it contained in this interval? Let's see. Is 35.1 contained in this interval? Well, 35.1 is not actually contained in this interval. 35.1 is not contained in this interval. And so in this case, I will reject the null hypothesis because the confidence interval is not contained in the interval. The confidence interval is not, the status quo does not contain is not contained in the confidence interval. So because the status quo, what we are debating, 35.1, is outside the confidence interval, we will reject the null hypothesis. So I can just put my lower bound here. I put the upper bound here. And then make a decision. I already made the decision. We reject the status quo. Why? Because it is not contained in the confidence interval. Will the researcher reject the null? Yes. The researcher will reject the null hypothesis because it is not contained in the interval. Reject the null hypothesis because it does not fall in the interval. Yes. Okay. All right. So and then, so that's all the question, but you can use confidence interval to test hypothesis, can do hypothesis testing whenever it's a two-tailed test. Whenever it's a two-tailed test, you can use confidence interval to do hypothesis testing. So that is what we just did. You can use confidence interval to do hypothesis testing. And also we can use confidence interval to do hypothesis testing on number 36, how to use confidence interval to do hypothesis testing. So let's go to number 6 again. 36 again. We rejected the claim with hypothesis testing. Let's use confidence interval and see what my calculator will say in number 26. So I'm going to clean. I'll go to start, do T confidence interval. because this question is also a T confidence interval, hypothesis testing. All right. So what is the mean? What is the X bar of this question? The X bar given to me in this question is, let's see, did they give, yes, X bar is 31.2. 31.2. And the standard deviation is 6.3. And the sample size is 15. And the confidence level they give me here is 95. Actually, this is 0.01. Okay. So because it is alpha is 0.01, now I have this is 99.99. Okay. And then I'm going to calculate. All right. So what I'm checking now is 26 contained in the interval? No, 26 is actually not contained in the interval. So I will reject the null hypothesis. The same thing that happened when we use the confidence level. So we can use confidence level, confidence interval to do hypothesis testing whenever it is a two-tailed test. So whenever it's a two-tailed test, we can use confidence interval to do hypothesis testing. If hypothesis testing is two-tailed, I can use confidence interval to do it. If hypothesis testing is two-tailed, I can use confidence interval to do it.